Hi, my name is Sam and I'm a co-founder of AutoDataMiner. In this video, I am going to show how we can use AutoDataMiner to analyze health-related datasets. For this purpose, I have selected a diabetes dataset and I am going to go over this dataset and build an interactive dashboard and extract some knowledge from this dataset using AutoDataMiner. So let us start. I have, as I said, I have a pregnancy diabetes dataset. If I open this data set, you'll see I have around 700 actually records here, and then I have multiple columns. So look, so if you see the first row of this, the first record of this data set actually is column names, and then the others are actually the real values. So here, for example, the first column is pregnancies, and then glucose, and then blood pressure, skin thickness, insulin, BMI, some features, age, and then at the end, the outcome. So outcome here is actually if the person has diabetes or not. So if 1 means yes and 0 means no. So actually the purpose of this analysis here is to see how we can extract some patterns, some useful information from this data set using AutoDataMiner. So let me close this data set and get back to the AutoDataMiner website again. So if you log in, if you just go to the AutoDataMiner.com and log in into the system, you'll see actually a link here called analysis. When you click on analysis, you see all the previous projects you ran, and by clicking on these projects, actually you can go, see the project, or in other terms, actually analysis, or you can actually start a new analysis. So you need to select actually a data file to start. So what I'm going to do, I'm just going to click on choose file and then select the file that I recently showed. And then I'm just going to say open and then upload the data. So after uploading the data, you need to answer to a couple of actually very simple questions. First of all, you need to select a name for analysis. So I am just going to call it a demo diabetes, for example. And that's fine, demo diabetes. And then in the next step, it asks you, you need to actually select the columns that you are going to consider in the analysis. So sometimes there are some columns that you feel there is no need for those fields to be considered in analysis. But here actually looks like all the columns I have actually are kind of related to this project. Again, on diabetes, right? So I'm going to select all of them. In the next step, it's asking you if you would like to select a target column. And it's explaining a target column is a column that you would like to see the impact of other columns on it. So yeah, if you click on this, you see again the list of all the columns, and I would say outcome is my target column, right? So I would like to see the impact of other variables, other features actually on the outcome, right? Which was actually diabetes. So then after this, I would just say start analysis. It takes usually between 1 to 5 minutes. For the system to generate the dashboard for you. It depends on the file size, the number of columns you have, or like how the server is busy, and a bunch of these kind of factors. But usually it's very fast. So let's wait to see how long it takes for us. I would say because this data set was very small, it should take less than a minute to generate the dashboard for us. Yeah, actually it was really less than a minute. Anyway, so if you see in the generated dashboard, you have 6 types of analysis. I would say 6 types of tabs here. So summary statistics, dependency analysis, cluster analysis, anomaly analysis, impact, and then prediction analysis. So in the first step, in summary statistics, as it's saying, actually the name kind of is very clear. It gives you some summary statistics about the data set that you uploaded. So here, for example, we have all the previous columns that we saw, and then we have the type of the column. For example, for pregnancies, the number of pregnancies, it was a numeric. For glucose, it was numeric. Or for example, for outcome, which was 0 and 1, it considered that as a categorical variable. And then how many missing values you have, how many unique values you have, what was the mean value, the median value. For example, what was the average number of pregnancies in this data? So you see, for example, around like 4 is the kind of the average number of pregnancies in this data file. And then something very interesting here, the distribution plot. So when you click on this distribution plot, you see actually the plot of this variable. So if you remember, that variable was pregnancy. So you see the number of pregnancies here. and then the count, how many, for example, number of pregnancies we had for 0, for example. So you see, for example, 106 people here had just 0 pregnancies, and then 120 of them actually were pregnant just once. So you see, I mean, the number of pregnancies here, and then even like you can see here, for example, they had the person with 17 times I mean pregnancies. So this is actually show you a kind of a distribution of that specific variable. You can, I mean, you can try other variables as well. Let's say consider this time like glucose. So glucose, if you see, yeah, this is actually the distribution plot of the glucose, and you see actually a number of people who are in the 0, actually the glucose level is 0, which is not actually in reality is not possible. So it looks like actually this is a kind of a noisy part of the data. And you know, you can, you know, play with this. I mean, you kind of, you know, click on those distribution plots, and you can see, I mean, all the I would say distribution of different variables. And you know, outcome, if you remember again, this was actually if the people, I mean, if that person was diabetes or not, if I diabetes or not. If I click on that, also you can see, for example, here we had around 458 people which actually didn't have diabetes, and the rest, which is 241 people, actually had diabetes. Again, I mean, you can play with this and see, I mean, that this, you get kind of, you know, kind of overall structure, overall distribution of each single column in your data set using this part. The second part is called dependency analysis. In dependency analysis, what we do here usually, it considers actually all the pairwise possible relationships between different variables. For example, again, we had pregnancies, for example, let's say the relationship between pregnancies and glucose, the relationship between pregnancies and blood sugar. I mean, all the possible pairwise kind of columns are listed here, and then you see if the correlation or the dependency was weak, or it was, for example, negative or positive, and then you can see the interaction plot here as well. And if, for example, if I consider, let's say, pregnancies and glucose, if I click on the show plot, so you see again pregnancies and glucose. So see, for example, people with like 0 pregnancies, this is their glucose level, like it's coming from 57 to we had like 198. So you know, you can see, I mean, again, the kind of the interaction between those two variables. Again, you can select, I mean, any of those. For example, let's say pregnancies and age. If I click on that, so you see a kind of, you see kind of something like this. So when they are older, I mean, usually, I mean, we have a higher number of pregnancies, and this is, I mean, quite obvious, right? So there are, I mean, again, you can see, I mean, again, kind of see, I mean, you can try different combinations here and see how they are related to each other. For example, another one's like skin thickness and BMI. If I click on that, so you see like kind of, you know, a positive kind of like relationship between these two. So you could say when BMI is higher, the skin thickness also is going higher. Although here we have some zeros, which are, again, I would say these are noisy part of the data. So anyway, so this was actually dependency analysis. The third type of analysis is called cluster analysis. So in cluster analysis, what happens? The system tries to group data. I mean, based on the definition of clustering, the system tries to group similar objects in the same clusters and dissimilar objects in different clusters. So you see, I mean, if you remember, we had like around 8 columns, right? So this system actually, what happens? It projects the data into 3-dimensional space. And you see, for example, we have actually the system actually clustered the data into 2 clusters. And actually, this was, I mean, the number of clusters, I mean, as 2 was kind of detected as the best number of clusters for this data set through the system. And when you click on, I mean, when you see, I mean, when you just hover over of each of these data points, you see, for example, the class number 2, this is the XYZ Z value, and then this is the record number. So in this way, you can go to the data set and see, for example, where, for which record is, for example, this person. So in this way, you can kind of map this visualization to your records. And if I go down here, I mean, this is actually more interesting. So this is the cluster prototypes. So cluster number 1, cluster number 2. So you can see, for example, in cluster number 1, kind of the average number of pregnancies of people is like around 5, but in cluster number 2 is around 3. Like the average glucose level is 140, but in cluster number 2 is 109. Again, like these people and these people, right? 2 different groups. And I mean, at the end, if you see outcome, looks like, you know, most of people, I would say all of people here in this cluster have diabetes, but people here don't have diabetes. So then, this is a very interesting fact here. So you could say these people do not have um, these people actually with these kind of feature values do not have diabetes, but these people have diabetes. I mean, the system was intelligent enough to divide these people into two type of diabetics and no diabetics. People. And then here actually this is the same records we had in the Excel table, and then here we have just another column is added called cluster label, which is cluster number 1 or 2, and then here this is the record number. So at the end of this table, actually you can download the whole table, and if you're, for example, a data analyst or a data scientist, you can just do more analysis. So again, this is the previous table, and what happened only is two more columns are added: cluster label number 1 and cluster label, and then this is the record number. So what you can do, for example, you can sort, let's say, this data set based on the cluster labels, and then these people are in, if you see the label here, these people are clustered as the first group, and these are the second group. So then, as a data scientist or data analyst, you can do, further analysis here. So anyway, let's go back to the dashboard. So the fourth analysis is anomaly analysis. So in this way, in this actually analysis, what happens? The system finds out that consider actually top 5% of records with the highest difference with overall structure of the data as anomalies. So you can see here again, the data set is projected into two. In a three-dimensional space, and then these red dots actually are anomalous records. And again, you can just see, for example, this is record number 5, and then you can go to the data set and see why. You can just match this record number to this to this plot and see why, for example, this person was anomalous. If you see, this is record number 5, right? And you see here this person is actually anomalous. So you can again, the same as like cluster analysis, what you can do, you can just go and download this table and then dig into this data in a more maybe technical way. But anyway, what happens here, again, using this anomaly analysis, you can find out people who are really outliers. For example, you might see people who are very young, there is no, for example, pregnancy, but they have diabetes. You can kind of play to see what happened to those people. Or it can be even noise. You can see, let's say this person actually is a noise, this is not a real data. This analysis help you to identify those people. Another one is impact analysis, which is very actually interesting. So what happens here? Usually, this system uses a logistic regression to model those people, that data set, and then it shows the impact of different variables on the target column, which was actually outcome, right? So again, if you are a data analyst or a data scientist, you definitely, understand this table. So you have features. It was the coefficient, the odd ratio, the probability impact, and the p-value. But if you're not, let's say, data analyst, you're not technical, it doesn't really matter. You need just read this part. This is actually the piece that you really, it's really important for you to learn. So see what kind of really valuable information is extracted here. So the first rule, actually, coming from the modeling result, 1 unit increase in pregnancies increases the odd of outcome by outcome equals to 1 by 1.146 times. In other words, it increases the probability of outcome 1 by around 3%. So this is saying every time you get, one more pregnancy, the probability of diabetes goes high by 3%. Another one unit increase in glucose increase also increases the odd of outcome with this time, and again like this one. So if you see, for example, if you increase the glucose level just by 1, although it is not actually too much, right? Because glucose level can be between 50, 60 to 200, right? So 1 is not that big. So that's why actually it doesn't increase that much the diabetes probability, but still it's around 1%. And if I just take a look at this one, 1 unit increase in diabetes in this actually variable increases the odd of outcome this much, and it actually increases, if we just mention that in terms of probability, actually is 22%. So again, if I just go back to summary statistic and see this variable, if see the distribution plot, so you knew this is between something between 0 to 3, right? So one level increases a lot for this variable. So that's why one unit increase in this variable actually increases the actually the probability of diabetes by 22%, which is huge, 23%. So this is, I mean, the type of analysis that knowledge that this part can generate. The last one is called prediction analysis. So in the prediction analysis, we try to predict the outcome, which is diabetes, yes, no, with other variables. And actually, this is a classification problem here. And this is actually the ROC curve. Again, if you're a like a data scientist or data analyst, definitely you definitely understand this. But anyway, and this is actually the precision recall curve as well. But and again, sorry, this is actually the visualization of the features. So when, for example, we are trying to predict the outcome, I mean, these features have the highest impact. For example, glucose has the highest impact when we are trying to predict if someone has diabetes or not. The second one is BMI. The third one is age, and the last one actually is, skin thickness. So you can see then, if, for example, you're collecting data, like you make sure that you're collecting, for example, glucose and BMI in a very careful way. Make sure that your measures are right. But anyway, and this piece also is very, very important. So here, what you can do, you can upload a new data set and then predict the value of diabetes. So if I just go back to the previous table here, if you remember, I had this one, right? So let's say now we have some people. We measure, like, let's say copy this part here. Let's say we have some people here, and we are going to predict the outcome. And let's say we don't know outcome. Let's say I have a number of friends. Let me create actually an Excel table here. Let's assume that I have a number of friends, and then I know, for example, this is their pregnancies, this is their glucose, and then I'm going to predict what is going to be the outcome for them. And let's say I know, for example, one person has one pregnant, and this was, let's say, 100, and then this one is some other value like 6. I don't know. Let me even remove these guys. I really don't know. Don't need too many people here. So let's just consider this one, and another one I'm going to add, for example, 20 pregnancies. This is like 200. This is going to be like 70. Some numbers. I'm just generating some number, but in reality, it can be real numbers actually. 50. This is 2, and then age is, let's say, 70. It doesn't matter. And then we just save this, and then I'm just closing this. And now if I get back to my on this dashboard, I can just choose that file. This was new Microsoft Excel. Let me just rename it here. New Microsoft. I'm just going to remove all the spaces because sometimes it creates some trouble for me. Anyway, I open it, and then I would say upload data. So what happens? The system predicts the outcome for this new records, and then I can just open it for those 3 people, if you remember. So now for these people, these 3 people that I created, I created a prediction for them. You can see the predicted outcome for the first 2 people is 0, they don't have, but the last one, the third person, has diabetes. And you see, even you can see like the probability of having diabetes or not having, 0 and 1, not having diabetes. So see, for example, for this person, the probability of not having diabetes is 94% versus 6%. Or for example, this one 63% versus 37%. Or here, for example, the probability of diabetes for this person is 56%. So in this way, you can kind of, let's say you have some new patients, you have those measures, and you're going to predict if they have diabetes or not. So in this, using this prediction analysis, you can predict the outcome. So yeah, this was the overall structure of this system, and the type of analysis that you can really generate using AutoDataMiner. Thank you for watching this video.